and see whether they were able to do the cleanup job or not. So it was a big problem for us. So doing after a lot of things, we got a small fermenter of around 100 liter. We produce these microorganisms in bulk, like in a fermenter. So that was also new thing for us. And after doing a lot of struggle, because there was no option for us, it was a matter of survival for us. So after doing all this effort, we were able to grow in the fermenter, in 100-liter fermenter. And initially we took the liquid culture in the barrels, but once we reached that site, most of these microorganisms, they died. There was lysis because there was no aeration, so all microorganisms died. Once we took the site was a Mathura refinery. There was a oil spill, pipeline leakage, and in around football ground of area was full of oil spill. So they gave us that area for testing. But this liquid, we used to come early morning around 4 o'clock, harvest this culture from the fermenter, filled in the jerry can and barrels and took the site. But once we reached there, all cells were lysis and nothing happened. So I think this was a failure. Then after doing a lot of things, then we thought that we should immobilize this culture, make in a powder form. And then after doing a lot of things, one of my PhD student, he tried on various type of material on which it can be immobilized, make in a powder form. Around 30 different type of material we tried. So this culture can immobilize on the material. And we want to see whether they will able to, these bacteria were able to alive in this carrier material or not, and how long they will able to alive. So like that, it took us almost 2 years time to do this type of study. And then finally we selected a carrier material on which these microorganisms were immobilized and powder and packed in this type of poly bags. So these poly bags contain live bacteria in the powder form, where the bacterial live count would be 10 to the power 9 cells per gram of this carrier material. So I think this was a lot of, after doing lot of effort, we able to immobilize them, make in the powder form, packed, and took the site and applied, and then the site was cleaned. So I think this was very good, encouraging for us. This has really motivated us that we have to take it further. And then this funding agency, we presented this program. They also like that we have come slightly different. Otherwise, people used to give presentation in the shake flask, take culture, and then they thought that we have made in the product form. We have developed the complete process. A product was developed. So they like this idea, and they have visited site, and they also saw that this was very good. And this refinery people also, they like this idea, because around a football ground area where they will excavate this contaminated soil, where they will put. So it was a big problem for them, and there was a fire in the spill site. So this was the big risk for refinery of any oil spill, oil leakage. So they said it's very good, and we want to continuously use this type of process or approach. So I think this was a good thing, and then we filed the patent in 2000 on this process. And after that, we started using this in the refinery. Then after one refinery, all refinery, they started. So there used to be refinery meet in every 6 months. And this oil company used to call us and present our case study, and they like. So almost all refineries, they started using. At that time, there was a 17 oil refineries in around 2001. So all refinery they started using, and then they also started giving money. So they started giving complete job to us on turnkey basis. So initially we were depending on funding on DBT around 40-50 lakh rupees for 3 years. This refinery started giving, one refinery started giving 40-50 lakh in for 1 year. So we got a lot of money, and then we started doing this. So like that, I think the demand of this product, oil zapper, we have created. So I think, as I am telling repeatedly, once we find the solution, then the money will come automatically. So we were depending on the small projects, struggling to get a small project with the funding agency. We were getting project without writing any project, without writing reports, presentation, money used to come and we used to provide this service. So it has become very good. We also started enjoying this. And whatever money we will get, we do research work for some other similar product development. So, but the demand has started increasing. So our 100-liter fermenter was not enough for us because we used to work 24 hours in the fermenter. So our team, the night team, they used to stay here, produce, and next day morning come and took this culture to make in the immobilize them and took the site and do the job. So we increased our strength also, manpower started using. Then we proposed our institute that we should increase our us to create this facility. So this is the fermentation facility, which is one of the best, I think, in country, where we have fermenter from 1 liter to 15,000 liter fermenter. All are imported fermenters, and all are computer control, automatic systems, very nice system. So this facility was created, we spent almost 50 crore rupees on equipments only to produce these microorganisms. So I think this is the one product that has been developed, tested, and started using for large scale application. All refineries, Oil India, Oil ONGC, all companies, they started using. And per year, we used to generate around 15 crore rupees from this product. Per year, 15 crore, where we were struggling to get 30 lakh rupees from funding agency for 3 years. So I think this was a very good example. So this is the fermentation facility where we have created a large fermentation facility where we have a separate production team, complete automatic systems where we have aerobic fermentation, anaerobic fermentation, different type of approach. We have a big nitrogen generating plant where we can produce 99.999% nitrogen for anaerobic fermentation. So all this facility we have created, and then started providing the complete solution, the turnkey basis solution. So I think that was the uniqueness. If we start selling this product, probably nobody will purchase this because these refinery people, they are not expert to use this product, they live microbes for this type of thing. So I think that was the unique thing for us, that we want to give the complete solution. They have to give us the problem and we give them solution, complete solution. So then only money will come. So I think we started doing all these things completely. So it's well known. So from 2000, we are continuously doing this. And now it's sort of a red contract with us. And we are doing this type of things. And then what happened, like recently there was a fire in Oil India well in Assam, where this fire was almost 3 months, and in around 1 kilometer radius, there was a major oil spill, which we have, even still we are doing this cleanup job. So in our country, it's well known. So apart from this, this was well known in our country. Then because ours is a research institute, like in university, we are also a research institute where PhD students are there. So then we proposed a startup company that time. So we wanted to keep a separate company. That time, this startup company system was not there. So we proposed to create a company. And so this oil company, they approached us that because they said that TERI is a research organization. So they said that we should create a separate company, and this separate company can provide this service. So we created a separate company known as ONGC TERI Biotech Limited. And that company we started with the paid up capital of just 5 lakh rupees. And now this startup company known as ONGC TERI Biotech Limited in 2007, this company is in operation. And I am a CEO of this company since beginning because I proposed this model and it's working very nice. So now this company is a profit making company. Every year this company is generating around 25 crore rupees by providing this type of solutions. The technology developed by from our group, from my lab, to provide these solutions to the end user. So this company is providing solutions on turnkey basis, and we generate around 25 crore rupees per year and profit around 12 crore rupees, after tax profit around 8 crore rupees. So now this company cumulative profit is around 70 crore rupees. So we are getting interest of around 3.5 to 4 crore rupees on cumulative profit. So you can see a large number of jobs were created for scientists and engineers. So I think this is the model that in which we now we stopped writing much projects to this funding agency, and we are doing the research work which has some potential, which has some applications. So I think this was the story about this oil chapter. Then in Kuwait, when this problem arises in 1990, so UN has given them a $3 billion, around 22,000 crore rupees for cleanup job. So in 2000, they got this, the Kuwait government, they got this money, but they were not sure how to use this, how to do the cleanup. So we were knowing this problem. So then we applied for the solution of that. But at that time they said we can't give this project to Terry only on nomination basis. So there was a tender. In this tender, there was a global tender, and in this global tender we participated. And then we got this project. This was around 250 crore rupees project for 3 years. So we and clean up of around 1 square kilometer area cleanup. Similar work which we are doing in India. So it was a similar work for us. But it was difficult because in the oil spill area, there was a lot of unexploded bombs, because during wartime, lot of unexploded bombs they dumped in the area. So the site was very dangerous. So entire work that we have to do, we have to open our site office. So this is the site office in Kuwait, where we have created in this project around 250 people worked on 24-hour basis. So this was the office, site office created in the oil field in Kuwait. Kuwait is a small country in near Iraq border. It's a very rich country. So in desert, we created this office where everything was done by us. So there is a 3 megawatt power generating system here. Nothing was there. So we took this project, created site office, and then initially we remove all the unexploded bombs. So this was the oil spill where we engaged around 100 people for removal of all unexploded bombs. So this work we engaged a retired army team, a company in which retired army people are working. So we engaged them to first remove all the unexploded bombs. We remove around 2,000 bombs from this site and disposed by Kuwait military. So like that, we have done this work at that. And we engaged a lot of teams. So this was the site survey work was done. So the oil, how deep oil has gone down, and what are the explosive material is there. So this was the site, I think in 2013 or so. The project started in 2012. So this is our team at the site. So we can see this is the lake, oil lake, which we have to do the cleanup job. And this is our team that time. And so I think a lot of survey work has to be done, where how much volume of contamination of this. So the payment would be on per metric ton treatment basis. Groundwater monitoring also we used to do, whether oil has gone down or not. So complete project, different type of tasks. And then, so this is the oil, floating oil that has to remove, and this floating oil has to process to recover the liquid hydrocarbons. So we can see that all liquid oil was lifted, and this is our bioreactor that here at Terry Gram. So we used to produce. So for Kuwait, we developed different microbes because their temperature is very high, high salinity. So develop the different microorganisms, which is very easy for us because our research team, they are exploring the new microbe, they are screening them and new microbes. So this was the new microbe for Kuwait. They can work up to 55 degrees Celsius and high salinity conditions. And so pack these microorganisms in the refrigerated containers, and then these are refrigerated container and put in the site. And this is the site in Kuwait where this microorganism applied, and then mixing was done, this microorganism. And all sort of parameters monitoring was done by a third party engaged by Kuwait Oil Company. And so this we installed a mini refinery for recovery of this free oil. So this machine we bought from US, 25 crore rupees we spent on this machine to process the liquid oil and give back to Kuwait Oil Company. So this was the lake where depth was around 2 meter deep. So remove all the liquid oil and then treated the entire contaminated soil and make it green. After that, we have done the plantation. So this fencing was done and plantation was done. Another oil lake. Uh, so I think this was a story of Kuwait project, which was a different story. So out of this, because that time in 2012, this Kuwait Oil Company, they were not sure which type of process has to done. But after doing this project, we demonstrated that bioremediation is the solution. So now Kuwait Oil Company has released a tender of around 10,000 crore rupees, around $1.6 billion, in which we participated in this project, and soon the result will come out. So if we will be successful, then we will get a big project from this. So now they want to do the cleanup by entire area by using only bioremediation process. So I think this is the very, very big size of project. And this company, as I explained you, that company has a OTBL, where ONGC share is around 49.98% and Terry share is 48.2 and 2% individual scientists. So the scientists, they have spent 2,000 rupees. Now it has become to 26 lakh rupees. So we can see how they can become sort of a beneficiary of doing this type of job. So this company started with the 5 lakh rupees, and now company's value is more than 300 crore rupees. Apart from this, we have developed another type of, so now our thinking is to do whatever has some applications. We don't want to do any routine things which already been done. So another project that we have done, as Akhil told, that from oil well, we can get only very less oil, around 25 to 30% oil. Around 70% oil still remain in the oil reservoir, which is not movable oil. So how we can get more oil from the oil wells, from the low producing wells? So we develop an again biological process. This was also well documented in literature, but very few real case study. So as I explained to you, that we wanted to do the real work instead of doing the things only in lab. So we got these microbes in laboratory and then tested in the oil wells. And after that, we started using this also large scale applications. So like this type of microorganism you can produce in fermenter and then inject in the oil well, and then oil production will increase. So in one oil well, we have to inject around 1.5 lakh liter of this biological solutions, and then oil production will increase. So by using this technique, now this we are providing this solution on turnkey basis to oil companies. So this company, this OTBL, is providing these solutions, and we have all the infrastructure facility to provide this service to oil company on turnkey basis. So this is the well where we inject this microbe like through this tubing, and then how we can see the production will increase. So we are doing this for one well, this company is charging 15 lakh rupees. So in one well, we can do this job in 2 days. So in 2 days, 15 lakh rupees we can generate. And so we have the complete team of in this company to provide these solutions on turnkey basis. And another approach we have developed, another problem oil company they are facing, this PDB means paraffin degrading bacteria, and crude oil paraffins, the wax, they are the problem. So from oil, crude oil will flow from oil bottom to surface. This wax will deposit in oil well tubing around 200 meter from the surface, where temperature will reduce, because in bottom, oil well bottom temperature would be around 80-90 degree. Once the oil will flow from bottom to surface, this wax will deposit. Once the temperature will reach around 40 degree, the wax will deposit. It's like a cholesterol deposition in our vessels, blood veins. So this oil company, earlier they used to pour the hot oil in the tubing. So with the hot oil, the wax will melt and then oil will start flowing. But next day again, this wax will deposit. So we, instead of hot oil, we will inject the microorganisms which they can degrade the paraffins. And these bacteria, they will make the film on the inner surface of oil well piping, and then they will not allowing this wax deposition. So I will not go in much detail, but it also took us 5-6 years to do the research work and file the patent. And now we are providing this solution also on turnkey basis to oil companies. We are getting around 8 lakh rupees to provide this solution in one well. So this is the another solution. This is the our infrastructure where we have this pumping machine where we can inject these microbes in the oil well tubing, and then this wax deposition can be prevented. We have provided this solution in the other countries, also in Georgia, where they have similar problem. So our team visited there, and we have done this type of jobs there. In US, as Akhil told, that I went in US in 2005 in Stanford University. And there were entrepreneur. So one company was there, and they read from internet about this, and then they gave us the project to me. And there we have developed a similar approach and created this facility. And so I think we providing these jobs on large number of wells. Every year we do around 40-50 oil wells of this type of solutions. Apart from that, we are doing basic research also. So PhD students, they are doing they are doing research on different topics which has applications mainly. Apart from basic work, molecular biology work, we do a lot of basic works also. So by doing all our research work, mostly they are competitive government awards, mostly Ministry of Science and Technology, Department of Biotechnology. We got a number of awards by doing this innovative application-oriented research work. Like this DBT as a Biotech Product Process Development Award, which I got many times this award. The criteria is that it has some application and how much money has been generated by these solutions. So that would be the criteria of selection of this award. So I think I will stop here with this. So now we are not depending on the small project, like we can do the things which we want, which have the applications. Not only that, the student will get jobs because they will train and they will get the jobs. So I think this is also a good solution that otherwise there's no job opportunity for the students, especially in biological sciences where there is no infrastructure, no industry. So if we will do like this, student will get job. And I think apart from this, we have given more than 100 crore rupees as a income tax to government. So I think whatever government has spent by research funding of my lab, I have given so many times to that money. So in around 8-9 years, we are given around 5 to 6 crore rupees as a tax to government every year. So I think this is a very good model, small model, but very good model, sustainable model, which government will get money. We will not depend on public funding grant, and students will get job opportunity. Industry will get benefit out of this. So I think under Atmanirbhar Bharat, this is one of the example. If we will do like this, I think it would be very good for all of us. So I will stop here with this.
Thank you very much, sir. And with your permission, sir, if there are any questions, probably then everybody is welcome to ask the questions to sir. Any query?
I think many of you are mute. So
yes,
would you like to ask, please unmute.
Unmute. Okay. So they can unmute themselves. Yeah.
So whoever wants to ask a question, please unmute and go ahead.
Good afternoon, sir.
Yeah, please introduce yourself and ask the question.
Sir, I am R. Sandeep from the Department of Microbiology. And so, sir, it was a very informative talk what you have given, and it was also very encouraging. So I would like to ask, like when we become confident about an idea, a novel idea, we prove that idea, and then we move on to large scale studies, like pilot scale studies. So what problems do you initially face when moving on from lab to the field? So what were the main problems, and how we should look at those problems?
Yeah, so I think this is a very important question, because most of researchers, they are stuck at this stage. We are not moving out of research from our laboratory. So as I explained you, because we are full-time researcher, we are not like teaching and research. So our job is full-time research. Although that time we got the option whether we want teaching or research, so we opted for research work. So the project that we have done, that we got a project for field trial. That time it was a big challenge for us to demonstrate whether whatever we are claiming it's working in the field condition or not. So that was the big challenge for us, and we did very hard work and very sincerity, and a lot of modification, lot of changes was done, and it was sort of we were sort of impatient of doing this. So initially the difficulty was that once the funding agency asked to demonstrate, we were not sure where we have to go. So initially we approached oil company, we have written many letters, but could not get any reply. Then finally we asked our head of organization, he has written to chairman of IOCL. And then IOCL chairman has written to refinery people, and then they allow us to go and discuss. Initially they said we do not have any oil spill in the refinery, because we don't want to waste oil, which is a very costly commodity. We don't want to waste. So initially they said we don't have such problem. But I think after doing interventions by chairman of IOCL, they allowed us to took us. Generally, these companies, they are afraid that we will complain to pollution control board, and then they will impose the penalty on them. So like that, lot of apprehensions about the industry people. But I think once the chairman of company asked us that we are a researcher, we will not do anything else. Just we want to do research work on this. We want to see whether whatever that we are doing, whether it will work in the field condition or not. So after getting this confidence, they allowed us to took us in the refinery and find the place where we can demonstrate. And I think we did a lot of hard work, and then we become sort of a friendship to the end user in the refinery people, and they also liked that. They also noticed that we are really working hard, and we are really trying to find the solution. So initially 3 years it was a very, very difficult and struggle for us. So I think many of us, we cannot we can't do such struggle. So I think that is the biggest hurdle to come out anything from research lab. And why we have done, because we were not having any option. We have to run our lab, research lab, so we have to get the grant. And there was no enough research grant from public grant, therefore we have to do this type of things. So I think it was a matter of survival for our team. Therefore, we did this extra effort repeatedly, not only once or twice. We have written so many letters but could not get any reply. But I think after that, we approached our head of organization, and then they wrote to their chairman of company and like that. So it's a long time, but we did not sit idle. We continue to do all effort. And then I think we were able to demonstrate. We also got confidence. Till we have not done this work and failed, we were also not sure whether it will work or not. But that time, because this was a requirement of funding agency also, and for us also we wanted to see. So I think that was a sort of a unique opportunity for us, and we utilized that opportunity. And as I explained you, self-initiative, uh, because of that only I think it happened.
Thank you, sir.
But now there are many things. Earlier this was not, but now there are many startup companies. So the startup companies, you can approach any startup company, or you can start your own startup company, which is free. You need not to spend any money. You can register under startup company, and you can demonstrate. You will get money for demonstration. So government will give grant to startup company to do this type of. So now it has become sort of a easier approach than it was not there earlier. So I think if anybody is having any useful things, many people are takers now. So I think this is my suggestion, that if anybody is having any useful things, it can be taken further.
Thank you, sir. Any other question? If not, I'll ask Dr. Devesh Sharma to give the vote of thanks.
Thank you, Akhil. I'm audible, right?
Yes.
Yeah.
Okay. Thank you, Akhil, for giving me opportunity, for giving vote of thanks for such a nice webinar and learning exposure to all of us. So I would like to, first of all, I would like to thank our eminent speaker today's webinar, Dr. Banwarilal Sir, the Director EIBD Terry, for enlightening us with his knowledge on the topic My Story, motivation session by successful innovator. And also in his whole seminar, it was a nice experience to see so many activities, so many stories, so many successful technology and models that one can implement and can bring from lab to the field. So that is very important thing that sir also said about this is how to bring the technology from lab to field, and how to give the economic model and other perspective to that kind of activities. So thank you, sir, for giving us this opportunity and sharing your valuable knowledge to all of us, so that maybe our students or our faculty member can explore more such opportunities in near future. I would also like to thank our Vice Chancellor, Sir, Professor Neeraj Gupta, for his continuous support and motivation to organize this kind of seminar. And I hope in future also we will get more opportunities and more exposure for such kind of knowledge in sharing webinars. And I would also thanks to our ISC President, Professor Sanjeev Kumar Panda, for his continuous efforts and guidance in organizing such activities, webinars under the umbrella of IIC Curaj. So that is a kind of teamwork that we have. So thank you, sir, for providing this all activities. And my special thanks to Akhil Agarwal sir for arranging many things for this activity, and other members also who are participating for regularly participating for organizing such webinar. And last but not least, that is our main audience participants who are actively involved or listening this webinar, patient, participating, and active participation, and I hope this will help them in future for developing more such opportunities, or to explore such opportunity in future. Thank you very much, sir, all of you. Thank you, sir.
Thank you, sir. Thank you very much. So, with the permission of President IISc, Professor Sanjeev Kumar Panda, I'll end this seminar. Thank you, sir.
Yeah, please go ahead. And thank you very much. And thank you very much, Dr. Banwari Lal.
Thank you. Thank you very much. Thank you. Thank you, all of you.
Thank you.
Thank you.